One of the main enhancements for this release is the ability to model universal tapered rings for TBM tunnels. So the workflow starts by defining the tunnel template, as we are defining every other TBM tunnel template. The only mention here is that the ring rotation here for this routine is not taking into account, so it should be 0 here. And take note that the configuration of the angles here will give you the first position of the ring. So if I would like to rotate this key to have it on the left side, I need to change the angles here. When it comes to the actual modeling, we're adding a tunnel corridor with a default unit that is set for TBM. We have added a new command that is called place TBM UTR, where the user can specify all the inputs for this workflow. So we have here the value for taper. Because I'm working in metric, this is a value in meters. The number of dowels, basically this will give you the pitch angle, the rotation angle. We are dividing 360 degrees to 60 dowels, so this will give you like 22.5 degrees rotation angle. The first ring position, basically, if this is set by default to 1, this will give you the exact position that you have defined in the template. But if I would like to start with another position, I can define it here. And for excluded ring position, in here the user has two options when it comes to modeling. Let's assume that the user is reusing his template. He has already modeled that ring for maybe for other projects. He already know the ring rotation matrix. So if we look in here, let's say we know how we can combine the rings. If this is the case, then we can specify here and tell to open tunnel. By default, we cannot combine position 1 with position 1. I would like to not combine it maybe with position 3, 7, 8, 10, and so on and so forth. When the user is entering the values here, basically we are creating the ring rotation matrix. But let's assume that this is a new project where we do not know how the rings will connect. So basically we'll just specify that we cannot connect position 1 with position 1 for the second ring. For this specific case, let's say that this combination here, it's giving us an issue where we have very close joints. So we can check to see what OpenTunnel has placed here. So we know that we have ring 1 and ring 2. And looking in the reports, we'll see the rotation angle for each ring. And using that information, we will be able to construct a ring rotation matrix. So if we look here, we see that for ring 2, the position is P7. So now we'll select the tunnel and say that do not combine the first ring with position 7. Now, if we inspect the results, we can see that we have here a joint that is good for design, but we can observe that the next rings are close enough. So we would like to expand the excluded ring position. So for this particular case, I know the excluded ring positions. So we'll see how a full model is created. Now we can see that the design is okay. We do not have joints that will give us issues. And also, if we will run a report, we will see the entire list on for each ring, how has been placed, with what position, what rotation angle. And also, we will notice that based on the first line that we have specified here, OpenTunnel is computing automatically the ring rotation matrix with allowable rotations. For the ring position list, OpenTunnel is listing all the rings with their corresponding position and angle, and also it's listing the deviation on the 2 direction for each ring that he has placed. So this is in the center line, in the geometrical center of the ring. And as an output also, OpenTunnel is constructing the deviated alignment on the portion of the tunnel. So if we are turning off our alignment and tunnel, we can see here that we have the deviated alignment.